Hi, everyone, and welcome to today's Rancher Online Meetup. It is September 25th of 2019, and we have a fantastic topic today. We are going to be talking about infrastructure as code and how to use it to automate provisioning of your Rancher environments, Kubernetes, applications running on those. We have a huge crowd here today, so hopefully we'll have, as usual, lots of great questions and lots of great discussion. We are expecting to be doing quite a few demos and going through a lot of different things. So I will hopefully keep us moving pretty quickly here at the beginning to get us right into the content. I'm Shannon Williams, one of the co-founders of Rancher Labs. It's great to be here, and I'm usually joined by Darren Shepard, my co-founder, but he is not here today. Instead, I am pleased to have two members of our team in Arizona joining us. Taylor Price is our senior DevOps engineer, and Taylor will be doing a lot of the demos today and showing you Terraform with Rancher. Taylor, how are you doing this morning?
Hey guys, I'm doing good.
Awesome. And then Bill Maxwell. Bill's a frequent presenter on the meetups. Bill's a product manager. He's been here since the very beginning of Rancher, and he'll be walking through really the structure of how to use this stuff. Bill, doing great?
Yeah, doing real well. Thanks.
Awesome. All right. So for any of you who this is your first time coming to a Rancher online meetup, we've been hosting these things now for about 4 years. There are dozens and dozens of them out there if you ever want to watch an old one. And from the beginning, we've always said this is a meetup, not a webinar. It's really meant to be a very interactive discussion. It's an opportunity for us to show you, how to do something and hopefully answer your questions about that topic. We have run many of these, and they usually go really well when you ask questions and you come in. But because they are more of an online meetup, just a couple things to keep in mind. We don't have a timer. This isn't an hour-long session. The content today will probably take a little more than that. I would assume we'll be here for at least 90 minutes. So just be warned. We do record the entire thing, so nothing to stress about there. Questions are always welcome. We want questions, don't hold them to the end. Ask them as you think of them. We'll try to answer your questions in the questions tab and go to webinar. But if it's a really interesting question, I might ask it out loud. I might, if I don't know the answer, we might ask it out loud. So, look for answers. If you ask a question and it hasn't been answered for 10 minutes, it probably means that I'm holding it to ask a little bit later. So don't be frustrated. It's probably a really good question. I just haven't had a chance to get someone to answer it. As I said, we're going to be demoing. This is not a slideware type of thing. Everything we do is live demos. We'll kind of try and explain a topic, then we'll dive right into demoing of that topic and how to actually do it. Because of that, sometimes things break, sometimes internet doesn't work, sometimes we goof on our scripts. Please be patient. We'll try to debug it on the fly, and if that doesn't work, we'll jump on to the next point. But we've had lots of success with this, so hopefully it won't be a problem today. I mentioned we're recording the meetup. All of these are kept up in YouTube. You can go back if you miss a meetup and you want to see what we discussed last month. They're always there. You can see how these go. Often they're, you can tell from the length, an hour and a half, an hour, 2.5 hours. We really do kind of keep the length tied to the topic and based on how many questions are coming in. Some of the recent meetups we've done have touched on a lot of the upcoming Rancher 2.3 features like cluster templates, Istio support, Windows Server support. We had a introduction to K3S earlier this year, K3OS, Rio, some of the new open source projects we're working on, we'll probably next month's meetup we'll be diving deep into Rancher 2.3 and upgrading from 2.2 to 2.3. So feel free, just jump back there to the YouTube channel. You can also find all these on our website under meetups, I think they are, or under events. But you're being recorded, so ask. If you ask a question, please don't put your credit card in the question. We do have a lot of people who attend over and over again, so it's a great community of people. If this is your first time coming to the meetup and just want to join in, we use the hashtag on Twitter, Rancher Meetup, to connect. So post a picture and I'll slap it on the wall. Tell us a little bit about what you're doing while you eat, while you eat your dinner in Europe and watch the meetup. Tell us what you're eating, and we'll all love to, participate. So there's a good conversation going on on Twitter. There's also a lot of discussion sometimes on the online meetup channel of the Rancher Slack. If you haven't already joined that, you can join at slack.rancher.io. There's 10,000 plus people on there, so lots of people to talk to about what you're trying to do with Rancher, with Kubernetes, with Docker, with Istio, with just about any topic you might want to get into. Okay, with that, let's dive into today's agenda. I'm going to do a 5-minute quick update on who is Rancher, for those of you who don't know, and some of the stuff we're working on right now. We will be then diving right into the infrastructure as code topic. Bill will be explaining really the principles of how we built out our Terraform driver, how we use it, what kind of core concepts we're trying to cover. Taylor will be jumping in and doing demos. I think they're going to, at some point, Bill's going to be doing a demo. So we're going to go through a lot of content. We're going to show really how to build out the cluster, how to build out your Kubernetes child clusters that are attached to Rancher. We're going to talk about actually deploying applications. We may use Rio a bit and show Rio. So lots of cool content, all focused on GitOps and infrastructure as code. Your questions that are remaining, we will answer at the very end. We'll provide any updates on other projects besides Rancher in there, like K3S, etc. But with that, I'm going to jump right into just giving you a quick overview of Rancher. For those of you who don't know, Rancher is a open source software company based in California and Arizona. We have about 160 people that work here and have been in business now for 4 years, working with organizations who are trying to build out Kubernetes as a platform in their org. Really the fundamental problem we solve with Rancher, the open source project Rancher, is around managing the interface between the clusters that you use to run your applications and the teams that actually have to use them. So with all of the growth of Kubernetes over the last few years, what we've seen is a real decentralization of Kubernetes within most organizations. Kubernetes is deployed, by individual teams. It's deployed for individual workloads. It's deployed in different clouds. It's deployed in different data centers. It's now getting deployed on the edge. It's used in development environments. And so, it's very common for us to see dozens, if not hundreds, of Kubernetes clusters. And at Rancher, we really focus on helping you build those clusters, but also in a big way focusing on the management, the operations of those clusters, and the security of those clusters. And that really is, in many cases, the big gap that most teams face as they really move from using Kubernetes as kind of a tactical tool to more of a strategic platform, supporting multiple app workloads. And that middle layer, we focus on 3 basic concepts. How do you operate clusters in a consistent way? How do you ensure that you're managing, your security and compliance policies, ensuring users can only access the right workloads, the right namespaces, the right clusters, and then how do you provide the tooling around there to make people really productive with Kubernetes so that they can, they have access not just to Kubernetes, but to the ecosystem associated with it. And, at the bottom level, we do a lot of work on, delivering Kubernetes distros. So, we ourselves provide 2 core distributions of Kubernetes. One is called RKE. That's our data center traditional implementation. It includes automated ops. This is what we're going to be talking about today when we talk about using Terraform with RKE. It's an upstream, consistent Kubernetes, very much configurable and easy to run on any infrastructure. We also have K3S, which is also upstream, also certified, but uses pulls out some things to really focus on small footprint and also really unattended operations. Very popular for deployment on your laptop, deployment in your CI flows, deployment in edge locations, and more we're seeing K3S used in just about every use case. And someone was talking the other day about a 400, 500 node Kubernetes cluster running K3S. K3S is just really optimized for operational simplicity. And so teams that are running lots of Kubernetes are also finding K3S to be really cool. I was in an organization a couple weeks ago. They were using, they're running a K3S cluster for every single application that they're deploying in separate locations around. Like this organization has, I think, 40 factories around the country. Each factory is getting a Kubernetes cluster that's going to be running their application stacks that are necessary to power, the manufacturing, the automation systems, the inventory management systems, things like that. But the reality is you're also going to run a lot of Kubernetes in the cloud, and there For most organizations, we recommend and see people using hosted Kubernetes clusters, whether that's EKS, AKS, or GKE here in the US, or it's AliCloud's Kubernetes service, or it's DigitalOcean's Kubernetes service. These all have the advantage of being fully managed, very cost effective, and supporting kind of deep integration with the Kubernetes clusters. The great thing is, regardless of what the Kubernetes distro is, you should be able to manage it with Rancher. So Rancher provides a unified management framework for any Kubernetes. It runs on and deploys, obviously, Rancher's RKE and K3S clusters, but it also can manage and deploy your cloud-hosted clusters. It can import an existing cluster, and across all of those, it provides security and policy management, all of the operational focus on how do you configure and upgrade and maintain those clusters and keep them consistent, the user management and auth to ensure who can access them, and a rich set of tooling, focused on things like, providing, monitoring, log management, service mesh, catalogs, and CI flows, all these types of things that make it easier to deploy and automate. So if you haven't seen Rancher, join us for one of our weekly online trainings. We run them every week. There usually are 80 to 100 people there just trying to get their hands on Rancher and learn it. We're about to release Rancher 2.3 next month. Over the last few months, we've introduced a lot of the new features already. We've talked about Istio, cluster templates, and Windows containers. There's quite a bit more. That should GA in the first half of October, so keep your eyes open for the next announcement, probably within the next 2 weeks, 3 weeks, and that it will be a pretty significant release. Lots of features, lots of bug fixes, lots of enhancements for scale and things like that. So I'm sure our next meetup will be going to that in a lot more detail. With that, I'm ready to start. Let's get into the real topic of the day and start talking about infrastructure as code, talking through using Rancher and Kubernetes with Terraform. And for that, let's turn it over to Bill. Bill, are you all set up and ready to go?
Yeah, I'm ready for it. Just gonna make me the presenter.
Right. You are the presenter now, I believe. Let me know if you can.
Okay. Great.
I can see your screen. You're good to go.
Perfect. So as Shannon said, we're going to be talking about infrastructure as code today, in particular kind of using Rancher and Kubernetes and just looking at the different workflow, our recommended workflow for what that could look like for you. And so infrastructure as code, is an industry practice that you have your kind of text editors and you're defining your environments the way you want them to look, implemented in actual infrastructure code. And then you'll commit that to a version control system. And then through an automated process, you'll have the opportunity to plan, observe, look at, and see what changes are going to be made, and then approve and or deny those change requests sort of as they roll out to before they roll out to production. But then ultimately, your goal is to get the state that you've described in your text editor to look like your production environments. And so you kind of want to do this by, when you implement this, you kind of get the added value or benefits that your changes, there's a history of changes in your environment and what they look like, and you get both kind of a change log, and also you get to see an easy way to go forward and backward within that versioning. And so having that ability helps increase your velocity and your speed at which you can make these changes. It's automated, and so things are very consistent. And so as you do that, you also reduce risk. The difference being between like when you would go to a system and manually make a change and then copy and paste, there's opportunity for error to sneak in there. And these automated processes, they sort of get in and mitigate that for you. And so the way we see it is, there's a couple different roles within the Rancher ecosystem. As there's the person that's responsible for provisioning and bringing up the Rancher infrastructure, the management plane, the folks that are responsible for setting up the policies, setting up authentication. Really at the high level, they're the ones that are delivering the kind of service to the organizations big and small, and provisioning out those clusters. And then there's the cluster admins and the cluster consumers. Really from that standpoint, they're consuming Rancher as like a cloud provider, or as any other infrastructure provider. And so we built the Terraform provider to meet all of those use cases. And so the nice thing about it is that whether you're in the cloud or on-premise, or you're using some other automation tool, the Terraform provider with Rancher 2 can be used just with Rancher. And as if you're still on-premise and moving to the cloud and need to get that a place to start with automation, this is a great place to start, because it has no other dependency. You can create your Rancher clusters. You can get in the habit of moving to an infrastructure as code. And if you've already got that practice, then integrating this into your workflow should be pretty straightforward and very simple. And so today, what we're hoping to show you is what that all looks like. We're going to bring up, from nothing to a fully functioning application running on Rio. And so we'll bring up the Rancher HA cluster, and through all automation, we'll bootstrap it. No human intervention, bringing it all the way up through the auth provider being configured, the admin password, the settings for the URL. You don't have to go to the UI at all in order to bootstrap Rancher using the Terraform provider. And then we'll provision a cluster, and then we'll upgrade that cluster, and we'll show what that looks like, and sort of how, as you're updating your infrastructure through source control Terraform modules, you can see what that looks like. And then we'll use that also to deploy an application, and that app will be Rio in this case. And then we'll step into kind of more the Rio experience, which has some very advanced Git-based workflows that are possible. And so to start out, what we're going to do is build out the underlying infrastructure of the management plane. So that's involved, in this case, we'll provision this on AWS. We'll get 3 control plane etcd nodes. We'll get 3 workers. We'll put them behind a load balancer. And then we're going to layer on RKE, which is the Kubernetes distribution provided by Rancher that'll actually run the Rancher application. We'll install Helm in order to enable us to install the Rancher HA application, which will go on there, and then we will bootstrap the Rancher installation using the Terraform 2 provider. And so with that, I will let Taylor take over, and while he's transitioning, now would be a good time for any questions.
Yeah,
Taylor?
there's a couple questions. Sorry, Bill, I'm muted there. Questions that was coming in was there any support, were any plans to like integrate with things like Azure DevOps or DevOps as a service types of projects? Anything like that? Any plans for those that you know of?
Not yet. We're working with Azure and talking with them quite a bit as more customers are coming on board and users. And so that's something we can look at. Rancher is 100% API driven, so it's certainly possible to integrate with other tools. What we found is that Terraform was very commonly used across a lot of our user base, so that's where we've been focusing our efforts at this point.
Okay. Another question was, does the Terraform support multiple clouds like Azure and Google besides just AWS?
Yes. So there's a lot of different components. So what's nice, for those not familiar with Terraform, Terraform is sort of like a cloud formation, or the DevOps thing that other DevOps tools that sort of spans clouds. It sort of gives you a common language to sort of and process to implement your changes, but it's not tied to any specific cloud. So We're using the AWS provider to provision VMs, but there's an Azure provider that'll provision Azure VMs for you and other Azure resources, and really integrates very well. Those are all, there's a really vibrant community around Terraform, and so each of those providers, especially with the big three clouds, the community support around those is really comprehensive and very well documented and supported. So you have so this isn't tied to any specific cloud. We're using AWS. We've found that is a very common one, and a lot of folks do use that, but again, not tied to it.
Okay. All right, I think we can keep moving.
Cool.
Actually, there was one other question that came in, and that was about bare metal support. So for infrastructure provisioning, does Terraform support bare metal servers? Someone said, similarly, will cluster, can we also support VMware environments, vSphere? Do you want to just kind of maybe answer those two about bare metal and vSphere?
Yeah, there is a vSphere provider that you can use to provision VMs on and integrate what we're doing. And again, and then for bare metal, I mean, it would depend on sort of, Terraform typically needs an API to interact with in order to provision and scope those out. It does have some hooks that maybe could use like running shell scripts or something along those lines, or triggering a config management tool to kick off a run. But as far as creating a bare metal instance, it would need an API that it could interact with. I'm not too familiar with those, but the neat thing about Terraform is that it's composable, and so you can swap out the infrastructure modules and then use that with the Rancher 2 module, which is independent. So if you're not using Terraform to provision any infrastructure or anything else in the environment, and you can use it just to provision Rancher and interact with the Rancher level concepts. And sort of what that does is you have like a Rancher cluster, for instance, that gets created, and then as part of the outputs, you get variables that you can substitute into other bits of your Terraform or shell scripts even, or config management that basically use those outputs. So getting the custom registration command, or getting the namespaces, or any number of things that kind of get exported through that, then can be fed into other bits. So it can be a small piece of the overall orchestration workflow, or it can be a large part of it. It really varies on sort of your environment and your infrastructure and what you need to do.
Great. All right, let's get into it.
Taylor?
Yes, can you guys hear me?
We can.
All right, perfect. Cool, so I have put together a repository here. It's Dr. Pebcax / Rancher as code. And you guys can take a look at that if you want. It contains the Terraform that's being used for this demo. And it basically, it has kind of 3 steps here. So we'll go over sort of each of these throughout the course of the demo, but we're going to start here with actually setting up a HA Rancher server. So let me jump over here. I've got the repository cloned. So for kind of related to the question about what different infrastructure providers Terraform supports. Here I've got all of the providers that I'm using for Terraform, and so that's AWS at the top, obviously. That could be swapped out, like Bill said, for Azure or Google Cloud or DigitalOcean or any provider, vSphere, anything like that. And then we have some more specific providers for the other tooling that we're using. So we're using the RKE provider here. So that's, to let us use RKE via Terraform. We're using a Helm provider, lets us install Helm charts like the Rancher Helm chart. And then we go into the Rancher 2 provider, which actually lets us talk to the Rancher API once it's up and running. And we have 2 of them set up here, one for bootstrapping purposes and one to actually use to talk to the API. So we'll talk about that in a minute. But first things first here, we've got to provision our infrastructure. For the sake of time, I've run this one already because it takes, somewhere between 6 to 10 minutes to provision, since we're bringing up, a bunch of instances and then a whole Kubernetes cluster. But we'll sort of talk through this. So we're creating a load balancer here. We're listening on port 80 and 443. And then we're kind of going through, we're creating a security group, allow us to access the servers, over SSH, and then, port 80, port 443. And then this is the Kubernetes API. In general, I wouldn't necessarily recommend opening that at all, but for the sake of the demo, it's easiest that way. So the security group will allow all of these instances we're creating and the load balancer to be accessed on these ports. Here we go into actually creating, some instances for Rancher. This section here is the control plane and etcd nodes for our Kubernetes cluster. For those of you who are familiar with Terraform, this will probably look pretty familiar. AWS instance is the resource type, and it's kind of one of the most basic building blocks, but it just takes a series of inputs that we have here specified. So everything from the number of instances we're starting, which in our case we've defined as 3. Everything from that to what AMI we're using, the instance type, the key name to use to access the instance, user data template, security groups, EBS volumes, like root volume size, tags, all that kind of thing. And then we have the same thing for our worker nodes. So it's essentially the same configuration. This is just for our workers. And so we're going to be starting up 3 control plane / etcd nodes and 3 worker nodes for this cluster. So it'd be what you consider an HA Kubernetes cluster. So from there, we create a load balancer for use for Rancher. So this will be the endpoint that we'll access to actually get to the Rancher UI and to the Rancher API. Yeah, you'll see here I've specified, instances that are in this load balancer. These are all the ones that are created by the Rancher worker resource. So that'll be my 3 worker nodes. And then we go ahead and we create a DNS record for this load balancer. And so this way we have the ability to hit it, on a specific domain name, which is both useful for remembering purposes. And when we go to provision Rancher, we'll also be using Let's Encrypt. So it'll generate a certificate for us automatically. We'll get a real SSL cert. So before we jump down to this next part, I just want to show the user data that we're using because it's kind of helpful. So our cloud config here, this is the user data. This is being added to all 6 of these servers. it's fairly basic. We're just adding public keys, and then we're running some commands here. So we're essentially just installing Docker. Really is what this does, and some other tooling. But basically, to run RKE, the base requirement is essentially a server with Docker installed. So that's what we're getting here. We're getting these servers, we're getting Docker installed on them. So when the server starts up, it will run all these commands. In order for us to know when the user data is done before we start running RKE, we're using what Terraform calls a null resource. So basically, we're running a script here to check to see if Docker is accessible. So we're running a Docker PS essentially. We're looping over that until it returns 0, so that we know Docker is now running on all of these nodes we provisioned. I'm running this on the masters, and the worker nodes. So once this is done, we'll be able to move on to the next command, which in this case for us will be provisioning stuff for backing up etcd. So we're creating an S3 bucket to use for backups, holding the backups, an IAM user that we assign a profile to, which is right here. It's just the sort of essentially the basic requirements for S3 backups that are listed on in the documentation for Rancher, essentially allowing it to put new backups in the bucket, get existing ones in the case of like a restore, listing backups, which is useful for viewing them and also for getting them, and then deleting old ones, because Rancher will automatically delete backups that are older than whatever retention policy you configure. And you'll notice here we're not calling out the bucket specifically by name. We're using a Terraform feature, which allows us to call out the resource by the name we've given it, and then there are attributes. So we don't have to know the ARN, which is is a locator that Amazon uses. Google and Azure and all of the providers use something similar, but we don't have to know what it is when we run this. Terraform will create the bucket for us, and so it knows. So this is sort of dynamic here. It doesn't matter what the bucket's called, what account it's in, what region it's in, anything. This will always resolve to whatever the bucket actually created ends up being. That's part of the power of Terraform, is that it allows you to do a lot of this stuff, without having to have very specific inputs. So we also create an access key to use. We'll be using this to input into Rancher, so that Rancher can actually use the IAM user we've created to put backups in S3. So that's all the infrastructure. So at the point that we're done running this infra.tf file, we have all of the underlying infrastructure. We've got Docker installed, we've got our S3 bucket for backups, we've got everything we need. At that point, we're essentially ready to start the process of installing Rancher. So from here, we know that, actually not installing Rancher yet. We need to make a Kubernetes cluster first. That's an important process. So now we have the infrastructure, we're ready to create our Kubernetes cluster. So we're going to be using the RKE provider to do that. Here, kind of the main resource of the RKE provider, this defines a RKE cluster. We're giving it all of the master nodes, which is the control plane and etcd. This is a feature of Terraform 0.12, allows us to loop over the list of Rancher master servers we created. So we've got 3 of them here. So it's going to dynamically load in those three, pass in their external public addresses, their internal addresses, the user, the roles that we want for those three, and an SSH key to use for RKE provisioning. And then it does the same thing here down below for the worker nodes, and it's basically exactly the same. The only difference here is we have defined just the role of worker, so that these have that dedicated role. We're giving it a name. We're just calling this Rancher Management Cluster. That's a Kubernetes thing. If you ask Kubernetes what the name of the cluster is, that's what it'll say. And then we're using some add-ons for RKE. So this functionality of RKE will allow you to automatically apply arbitrary Kubernetes manifests to the cluster when it brings it up. The contents of that is essentially just doing the initialization for Helms. This is creating a service account for Tiller and then creating a cluster role binding so that Tiller has permissions in the cluster. Since RKE does automatically create clusters with RBAC turned on, we need these things so that Tiller has the permissions required to function. So at this point, we've got our add-ons. We're also here configuring etcd to do backups to S3. So we've got our backup configuration here. So we're doing one every 12 hours, and we're keeping 6 of them. You could, of course, change these to any arbitrary numbers. And then we want to do S3 backups. So we're using this resource here. We're passing in it, the access key of the user we created, a secret key for that user, the name of the bucket that we created, the S3 bucket, our region, a folder inside the bucket we want it to put the backups in, and the endpoint for S3 in our specific region. And when this resource runs, it'll actually connect out to those 6 servers and turn them into a Kubernetes cluster. So once this resource exits, you have a functional running Kubernetes cluster, and we output the kubeconfig for that cluster so that you could connect to it, via kubectl or, whatever other tooling you want to use. So at this point, we've got a functional Kubernetes cluster, and we'll go up to the Rancher HA file here. And at this point, we are now ready to begin actually installing Rancher. So we have our nodes, we have our Kubernetes cluster. Now we're going to install Rancher. As part of that process, because we are going to be using Let's Encrypt for certificates, we've got to install Cert Manager. Here we're installing Cert Manager 0.10, and what they've done is they've split that installation into 2 parts, essentially. They want you to install their CRDs, which is custom resource definitions. They want you to install those before you run the Helm chart. So we're reaching out. This is from their official documentation. Basically, you run these 3 commands. So you do kubectl apply, you grab their CRDs from GitHub, install those, you create a namespace for Cert Manager, and then you add a label to that namespace to disable validation. And this is a Cert Manager thing, but essentially this annotation, without it, Cert Manager will not be able to install itself because it won't have the necessary permissions to create all the resources it needs. So when you come in here, it runs this command, those 3 different things in the script, using the kubeconfig that we wrote out before. And from there, we say, okay, so now the CRDs and the namespace are created. We are able to actually run essentially a Helm install. We're able to install the Cert Manager chart. And so we use depends on to make sure that this is finished running. before we start the Helm chart. That way we know the CRDs and namespace exist. It's safe to run the Helm chart. We are pulling in what's I think still the latest. It's at least very close since I wrote this Terraform. Calling out the chart, the namespace we want installed in, and we're installing Cert Manager. Once Cert Manager is installed, now you move on to installing Rancher, and it's also done via Helm chart for an HA configuration. So we basically do the same thing here, where we call out to the Rancher chart. We're calling a specific version, which we've defined in a local. In this case, it is version 2.2.8, which is the latest stable at this time. And we're installing it into the cattle system namespace. We're also we're overriding some of the defaults, so we can set the host name, which is what we've created as a record in Route 53 for us to use. We're setting our TLS source to Let's Encrypt, and then we're configuring Let's Encrypt email and environment so that we can get a Let's Encrypt certificate generated for us automatically. And again, we're linking these together so that this does not run until after Cert Manager has been installed, because we do not want to try and start Rancher and talk to Cert Manager before it's actually running, since that would not work. From there, we just wait for Rancher to be healthy and to have a certificate. So this takes a minute or so essentially. Rancher starts up, talks to Cert Manager, and it takes a little bit of time for Cert Manager to get a certificate and for it to be applied. So we're looping here over this, checking for the certificate. Once we get a good response back, we've got a solid, valid certificate, and Rancher is responding. We move on, and we're ready to actually bootstrap Rancher. So normally when you start up Rancher, if you visit the UI the first time, you're prompted to change the administrator password. And then if you want to use the API at all, you would then also need to go and generate an API key. And you're also asked to set the server URL. So this resource, Rancher 2 Bootstrap, what it does is it sets the password for the admin user for you automatically. It creates a API key that you can use, and then it will also set the server URL. So that way your cluster is actually fully up and ready to be used. There's no manual intervention required here, to finish setting it up. At this point, you have an API key, and Rancher's all configured, so you can go and do more things with Rancher now. The final thing we're doing here is we are configuring the GitHub auth provider. So when we go later to log into our Rancher server, we'll be doing so via GitHub auth. And I've created an OAuth. I've created OAuth tokens in an org for this. So that's what these client ID, that's the OAuth ID in secret. Access mode is a Rancher thing. It lets you specify if you want to have to essentially allow anyone with a valid GitHub. You can allow anyone within a certain org, or you can limit it to specific users or groups, or things that you've specified. And so I've got it set to restricted here, which means I have to specifically allow particular principals in, which is what I've done here. Allowed principal IDs. I've listed the local admin user. I've gotten that from a data resource for the user. I've gotten the ID of it, so that's the local user. And then I've listed a GitHub user, which is mine, a GitHub org, which is a sample org I've used, and then a team that exists inside that organization. So anyone inside this team can log in, and then anyone inside this org can as well. For demo purposes, these are just the 3 types: user, org, and team. Those are the 3 types that the GitHub auth provider supports. So at this point, we have this environment here, which was set up using that Terraform. Like I said, I provisioned it ahead of time because it takes a little longer than I'd like for waiting on in a demo. But this is what you'll see when you visit, the page after running this Terraform. So I ask you to log in. So you'll log in with GitHub. In my case, I'm authorized, and I see my Rancher 2 server here. It didn't ask me to do anything. In this case, I have a demo cluster set up. We'll talk about that next. But I've got a fully functional local cluster, which is where Rancher is installed. You can see I've got 1, 2, 3, 4, 5, 6 nodes. 3 of them are etcd and control plane. 3 of them are workers, and everything is set up the way I want it. I've got a valid cert. I'm good to go. So I'm ready at this point to start actually using Rancher to do things. At this point, I think probably switch back over to Bill.
Taylor, before we switch over, there were a whole bunch of questions that came in about this. I think maybe one of the best ones to start with was one that Ronnie asked, and he said, why do we need to provision a Kubernetes cluster prior to Rancher? Isn't Rancher supposed to provision the clusters? It's I think maybe you can talk a little bit about, how we do HA and Rancher and why we use a Kubernetes cluster to do that.
Yeah, sure. So Rancher actually runs as a deployment. When you're running an HA configuration, it runs as a deployment inside of Kubernetes. And the main reason for that, is kind of orchestration related. So to have an HA system, with a shared backend, which in this case is Kubernetes, you kind of need an underlying Kubernetes cluster. The single node installation actually also has a Kubernetes cluster embedded in it. It's just sort of a single node. So the Docker container single node installation method, you start up a Docker container, and when that starts, it actually does launch a tiny little Kubernetes cluster in there for Rancher to use. Rancher stores all of its information, users, the clusters that are attached to it, catalog apps, all the settings, everything. It stores it in etcd, via custom resources. So, for an HA configuration, you need multiple Rancher servers all talking to the same Kubernetes installation, and for it to be truly HA, your Kubernetes installation would have to be HA as well. Otherwise, it doesn't matter how many instances of the Rancher server binary you're running. If your Kubernetes cluster goes down because it's a single node, everything will stop working. So technically, you could run this same installation method on like a single Kubernetes node cluster, but it wouldn't really be very HA because you'd be relying on that single underlying node.
Awesome. There was another, I think it was a good question that Raj asked, which was, is it also possible to create a Rancher managed cluster via Terraform? That's what we're going to be showing next. So
yeah,
think of architecturally what Bill showed, right? This is the HA cluster that is your Rancher control plane. Now we're going to go show a bunch of Kubernetes clusters themselves getting created, and then we'll talk about applications. So we're working our way down the stack from the management plane to the Kubernetes clusters to the applications stack. Okay, I think we can, there's lots more questions. Some of these, Bill, I probably need your help with, so if you can respond to a few of them, that'd be good. But why don't we switch back to the presentation, and Bill, are you gonna walk through the next slide or two?
Yeah. So thanks, Taylor. So what we just saw was, kind of to recap, was, we provisioned this is what you saw was the role of someone who's responsible for delivering Rancher to the organization, who needs to bring it up and host it someplace and install everything and get it up and running. And so what we've seen here is, from nothing all the way up to a running instance of Rancher. And with that, you're now ready to sort of turn that over to the next phase. And so in this next phase, what you're looking at is provisioning clusters for users, or how does a user get a cluster? And so depending on your organization's model for that interaction and how you want to provision a cluster in Rancher, that will define sort of who's doing this. But the Rancher 2 provider interacts with the Terraform provider, interacts specifically with the Rancher concepts. Definitely want to clarify that the Rancher 2 provider it brings the Rancher concepts into the overall Terraform ecosystem. And so we're just a component within that broader system, as you sort of saw in Taylor's demo there. We're also leveraging components from AWS, we're leveraging components from RKE, we're leveraging components from Helm, and these are all separate components that get kind of composed together to form one stack. And so that's sort of really the power of Terraform. And so each component can be interacted with independently. But what we're going to see next is how now to leverage the Rancher 2 provider to provision a new cluster for a user. So we're going to create a custom cluster, and then in Rancher, and then as the output of that, we're going to get a registration command and then provision some VM. We're going to create the Rancher cluster and then provision some VMs. Again, the control plane, the workers, and the load balancers. And so as those come up, they'll get that registration command through the original Docker run, and those will tie back into Rancher. And Rancher is actually going to lay down, do the provisioning of Kubernetes through RKE on that cluster. So that's sort of the workflow that we're going to observe there. And again, these components are the way that we can provision clusters in Rancher. We have imported. So if you've got clusters that you've built through other systems, you can import those and get those under management in Rancher, and so you can create that type of cluster. We have the custom cluster, which if you're doing a lot with Terraform is probably your best option, because you probably at that point have Terraform to build out your compute infrastructure the way you like it. You have your networking the way you like it, all automated. And so what this does is, you can use Rancher to just feed into that automation process that much easier. But you can also create node templates with the Terraform provider, and with the Rancher 2 Terraform provider, create node templates and create clusters and node pools, and then have Rancher actually do the provisioning of VMs or the EKS clusters or GKE clusters. So you have a lot of options and flexibility, and depending on your use case and whether you can use those components today or not, will sort of drive that decision. But what we see is most commonly when you're doing a lot of automation is the usage of the custom cluster. And so once we have that cluster provisioned, and it'll be running for a while, and then sort of the next part of that is to come through and update your code, your infrastructure as code, to say, okay, now it's time to upgrade my Kubernetes version. What does that workflow look like? And so we're going to see what that looks like next. And so, Taylor.
Yes, I will handing it over to you.
All right, you should have it.
Okay, perfect. Yeah. Cool. So for the next step here, we're going to be creating a Kubernetes cluster that is managed by Rancher. And you can see here, I've created this one ahead of time, but we're going to actually attempt to upgrade the version of Kubernetes on it during the demonstration here. But I've created it. It's 6 nodes, and it's kind of the same setup. It's 3 workers, 3 control planes / etcd nodes, and I've created it running Kubernetes version 1.13.9. So we're going to attempt to update it during this, just to sort of show off some of the functionality available the options, when using Terraform. So let's look at the module here really quick. We've got some of the same pieces here. We've got our AWS provider, and then we don't need any of the other ones because we're actually going to be using Rancher to provision Kubernetes and everything. So we just have these two providers in this case, but we do have essentially a lot of the same, infrastructure code here. So we've got to actually launch instances. So we've got, our cluster masters here and our workers, and a security group for them so that they can be accessed, for any services, any applications we deploy onto them. We're just assuming essentially at this point that you want to be able to access them on port 80 and port 443 for the Nginx ingress. So we create our infrastructure here, and then from there, essentially the next step is to tell Rancher 2 that we want to create a managed RKE cluster. And so this config, we've defined a Kubernetes version here. Specifically, we've called out 1.13.9, which is an older version. We're defining and configuring a cloud provider. This is AWS cloud provider since we're in AWS. So this cluster is brought up. It will have the the AWS cloud provider enabled and functional, so that we can use all of that functionality, like services type load balancer and EBS volume, storage class, all that stuff. And then we're also setting up etcd backups for this cluster. And so kind of a similar setup, actually basically 100% the same as the Rancher Kubernetes cluster that we configured before, the Rancher management cluster. We're doing, I think this is probably reversed. I think we're doing every 6 hours and we're keeping 12, or I think I had it the other way around before, but we're then passing in, backup configurations. That's, the access key for the IAM user, the name of the bucket, the endpoint the S3 is at, our region, a folder to put these backups inside the S3 bucket, and then the secret key of our IAM user. And we're using the same IAM user we created in the previous step. So just sort of go over this. This is a Terraform thing, but we're using our remote state. So we use this a lot in this module. And we've set it up here. We've set up our remote state data source so that we can grab anything we've output from the Rancher server Terraform module that we ran. So we're using this here to do things like pull in the IAM user credentials, the S3 bucket we've created in the previous step, and grab the API URL for our Rancher server and grab the API token we've created in the previous module. So we're doing all of that by pulling in the output from the previous Terraform run that we did in the other module. So it allows us to use the things we've already created to then go even further. So this is the only resource that's needed for this. Once you have infrastructure, you just use this one resource. And what this does is it creates a cluster inside of Rancher, and as an output of this resource, we get a registration command that we can run. So any server we run that command on will be bootstrapped and added to our new Kubernetes cluster. And so you can actually see that if you look in cluster, in the worker or the master thing here, we've got our user data. So we're using a template for user data, and we've got that defined here at the bottom. So you can see as a variable, we're passing in this registration command. So this is our Rancher 2 cluster resource. we called it user cluster, and then we get our cluster registration token. And for the worker user data, we're passing in the worker flag to specify that we want this one to have the worker role. And we're doing the same thing here for the master nodes, except we are passing in etcd and control plane because we want them to have those two roles instead. And again, our user data script here is almost exactly the same as it was for the Rancher server cluster, with just the addition of this registration command on the end here. So what this does, the registration command is it's essentially a Docker run statement, and it pulls down a image that's used to talk back to the Rancher server, and it contains like a registration token and some other things so that new node you're created is authenticated, and the Rancher server is able to push configuration out to it. In this case, we're also setting via the internal address flag, we're setting the internal address of each node so that Kubernetes is aware. So the cloud provider will configure the external address, and then we're just sort of specifying the internal address here so that Kubernetes will be aware of both the internal and the external IPs. But once these nodes are up, we have a fully functional user Kubernetes cluster, and that's what you can see here. This cluster demo. This is what we have bootstrapped with this Terraform, and you'll see again, 6 nodes, 3 etcd control plane, 3 worker. They're all running Terraform 1.13.9. So what we're going to do is we're going to attempt to update them to, where did I put that here? To Terraform, or sorry, to Kubernetes 1.14.5, right? So we're commenting out this old one, and we're specifying Kubernetes version now to be this new version. So we're going to save this, and we're going to commit it to GitHub. Right, so I'm pushing it directly to master to show this, but probably a PR is more appropriate. But it's been pushed to GitHub now. And for our automation, we're using Terraform Cloud, but there are lots of different ways to automate the execution of Terraform. Once it's been pushed somewhere, and any CI system can be scripted to do this. The Terraform Cloud offers kind of a nice UI and process for it, but it can be done, with Jenkins or GitLab CI or any platform. So just to sort of show here, this is the plan. So it's running a Terraform plan here, which shows us what is going to change when this executes. So it says that, of course, our user data is going to change, and I'm sorry, it's going to be red. Sorry, I'm looking for the changes. Here we go. This is the change. So our cluster is going to be updated, and it will show down here. Kubernetes version is changing from 1.13.9 to 1.14.5. Right, so that's our change that we're going for here. So I'm going to confirm it, and then Terraform Cloud will start actually running that apply for us, right now. And sort of as it starts to do it, we'll switch back over to Rancher, and we'll look and see so it's doing it right now. So it's updated the configuration of this cluster for us. Here now you'll see it says Kubernetes version is 1.14.5, and it's now going through the process of pulling down the new images and components that are required for the newer version of Kubernetes. So this will take a minute or so. But when it's done, we'll have an upgraded cluster running 114.5. And that's it. For configuring a Rancher managed Kubernetes cluster, it's pretty simple. All you need is some nodes, and then this one resource will give you everything you need to actually turn those nodes into a Kubernetes cluster, with etcd backups and cloud provider configuration. If you want to change any other settings, you can also do it through here. We have some examples, for instance, of a CIS benchmark hardened cluster. You could pass all that configuration in here as well if you wanted to create hardened clusters. Anything you can do with RKE, normally you can do it through this Terraform provider. So it's very powerful. This will just take another minute or two, but if we had any questions or anything, I think that's sort of this portion of the demo. Did we have any more questions we wanted to go over, or should I pass it back to Bill?
No, Taylor, there's a bunch of questions. Thanks. This is coming up. There's a few questions about this. One was, when you're doing this upgrade, Francois asked, is the full cluster unavailable, or are you doing a progressive rollout, or do you have a choice? What's the rollout experience like? Excuse me.
So it does a somewhat progressive rollout. However, we don't really make a specific guarantee that there will be no downtime of services. It does sort of roll through them, but it doesn't just blast them out all at once. But yeah, there can be small amounts of downtime for like the control plane, and depending on the update you're doing, like this one going from 113 to 114, we're also replacing the Kubernetes DNS provider. So there can be some short downtime while it's replacing components.
So if you needed to do a zero downtime upgrade, you might want to orchestrate it differently, or do it during some kind of what's the recommendation for someone who had a zero downtime requirement and they needed to upgrade a cluster? Is there a scenario where that's doable, Bill? Maybe you can chat about that, or is that something you're looking at?
So that's a big focus of 2.4. Primarily, we're going to be focusing on making sure that you have bringing fine-grained control to how the worker nodes get updated, and the system add-ons, particularly DNS and the ingress controllers. The main focus is really, it's not so much that you need a zero downtime Kubernetes upgrade, it's that you really don't want your applications to go down. And while we recognize that having the control plane as zero downtime as well is desired, and so we're going to be working on that as well. And sort of you'll have some flexibility of being able. We already manage etcd. We can upgrade it without breaking quorum, and that one's very well orchestrated today. Bringing that next to the control plane and being able to roll through each of those, so that if you do have automation and integration against the Kubernetes API, that stays up. And then really delivering the control that you need on the upgrading of the application servers, or the workload servers. Cool. And that's a focus for 2.4.
Okay. The other question, there was a couple of people asked, Wesley and Santakumar asked, how do you update the actual Rancher 2 via Terraform? Like if I want to do a Rancher version upgrade, how would you do that?
So that is part of the previous module. With what I've written here, essentially, I've set the Rancher version here to 2.2.8. If I wanted to update this to like 2.3 when it comes out, I would just change this and then run Terraform again. And basically what that triggers is this Rancher version local is used in the Helm release resource. So that triggers a change there, and it sees it's a newer version, and so it will trigger another Helm, another Helm run, which will upgrade the version of Rancher. So that's really all there is to it. You would just update wherever it is you specified the version of Rancher you're trying to use, and then you'd run this again, and it will take care of updating Rancher for you. That's what we're talking about, or we're talking about the Kubernetes cluster underneath Rancher?
No, in this case, we're talking about Rancher, the management server cluster.
Yeah.
But there was another question that kind of goes back to what we were talking about with the Kubernetes cluster, with the child clusters. And Ronnie asked, he said, what if the upgrade failed? Will the code on Git and the actual state diverge? So we're back to that demo when you just did the upgrade, what happened if there was a failure in the upgrade?
So yeah, you would run into a situation where the code, so your code on GitHub and the actual state would diverge. However, Terraform handles that by sort of having, two pieces. Basically, there's the Terraform that you write, and then there's a state file. And so Terraform, if you ran it again, Terraform would be aware that it was not in the desired state, and it would tell you. And so essentially you'd have to figure out what happened, why it failed, and then resolve that. And you could easily resolve that, depending on what it is, by modifying your Terraform and then running it again. So yeah, it can happen that the code that you've written here is not the actual state, but Terraform manages that in a state file. And so it's aware when you run Terraform again, or you do another plan, or if you do a Terraform refresh is another command, it will tell you that your desired state is not the actual state.
Okay. Bruno asked kind of similar question, which says, how do you deal with changes from users made through the UI? Is it possible to sync or merge changes into the Terraform files automatically?
No. So essentially, Terraform doesn't know about anything that you haven't told it about. For instance, I've deployed this Kubernetes, this user cluster. I've deployed it with Terraform here, and I've specified a version of Kubernetes. If someone were to go and deploy an application onto it manually, that resource would have to be imported into Terraform if you wanted it to be managed by Terraform. Otherwise, Terraform would not touch it.
Yeah.
There's no automated process for that. It could potentially be scripted, but there's not an automated process for it.
So people that wanted to prevent that would probably just control access to the cluster, and you ensure that the only access was coming through kind of a GitOps mechanism, if that's how they wanted to implement it. Is that fair?
Yeah. Generally, that applies to anything infrastructure as code, GitOps related. It can't manage what it doesn't know about, and so it's the same with any cloud provider, any system you manage that way. The whole idea is that you don't allow manual changes, because those are not tracked in the system, and so you don't get all the benefits of the of the velocity and safety and change control and stuff. So you tend to try and disallow manual changes.
Okay. There was another question Francois asked. He said, I can see that the node on 1.14.5 are marked unavailable. Is that normal? And what does it mean exactly?
Unschedulable. So those are, sorry, did you want to?
Yeah, I can answer that. Assuming that's what he meant. So
yeah,
unschedulable.
I think unschedulable.
Yeah, okay. So those three nodes that are marked as unschedulable, those are the etcd and control plane nodes. And so that's a piece of Kubernetes functionality. Basically, what it means is they are they're marked with taints, is what Kubernetes calls it, to ensure that your workloads, your applications that you're trying to deploy, don't get deployed onto an etcd or control plane node. So that's the whole idea of having a separate role for workers, is that you want your workloads to run on those, and you generally don't want to run those things on the same server that's running your data store etcd or your management API stuff, which is the control plane. It's possible to override it with toleration, is what Kubernetes calls that. Here in the UI, we label it as unschedulable because by default, it is unschedulable unless you override that with a specific toleration.
Okay. 2 more questions. One was, how do you restore the etcd backups for a cluster from S3? Like if you wanted to restore a cluster from an etcd backup, is that possible using the Terraform approach?
Yeah. So for the managed cluster, so I guess it's sort of a good thing to show. So for the Rancher 2 provider, there's documentation for all the resources it has on terraform.io. It's in their docs directory, along with all of the other providers that are supported. So you can kind of come here and see what stuff is supported. Essentially, I'm trying to remember the exact way you do it. Let me see here. Yeah, actually, I think it's this separate resource. I feel like I gotta look it up. Oh, that's the data. I'm trying to remember how you do it. There's so you can do it. Actually, you know what? I'm not sure that the Rancher 2 provider supports restoring from it. I think it just configures the backups. Let me double check really quick. Let me look at the cluster configuration here. It's not here anymore. I keep going to the data instead of the actual resource that I'm looking for. Let's see here. Yeah, that's right. So that's right. The Rancher 2 provider does not support restoring from a backup for you, which is actually kind of it's a little bit by design, because generally when you write your Terraform, you want to write it in such a way that you can apply it over and over again without it causing changes. And if you were to write Terraform that would restore you from a backup, it would execute every time, which would be really annoying. So you would write the Terraform, run it, restore from backup, then you have to change the Terraform again. So there's a way to do it. You can use Rancher's API or the UI to restore from a specific backup if you have a failure situation. And RKE also supports that for your underlying Rancher cluster. So restoring from a backup is probably not something you would do in normal GitOps, because it is like a special disaster recovery situation. I'd have to check. I'd have to look if the RKE provider supports it, but it probably also does not directly within the provider. You would generally be recommended towards for your Rancher managed cluster. You'd be looking at the RKE command line tool, which you can use with the outputs that we provided. When we created that Rancher management cluster, you can use the RKE command line tool to restore it from a backup, or with the Rancher managed cluster, you'd be looking at using either, you could do it through the UI, or you could use the API or like the CLI to do it, since that is kind of like a one-time operation.
Guys, why don't we keep moving? I know we have a whole nother demo we want to get to. There's lots of questions, lots and lots of questions. So, but why don't we turn it back over to Bill, get through this, and then we'll talk through a little bit of the app deployment, and then we'll finish up with all the questions that haven't been answered. I know a lot of people have to leave. If we don't get to your question on here, I apologize, but we'll do our best to get to as many as we can. Go ahead, Bill.
All right.
Are you muted?
I was, and now I'm back. There we go. Cool. So in this next part, what we're going to look at is a product that we call Rio. Over the last 6 to 8 months, when we've been talking with users and in the community and of Rancher and of the broader Kubernetes community, and just looking at what CNCF's doing, it's been incredibly active. Everyone's sort of asking similar questions of like, how do I get service mesh? I really want to be able to do blue-green deployments, or I need to be able to do canary deployments, or I need to try, I want to have tracing through my microservices architecture so that I can see the requests. I need better visibility. And we started kind of hearing these themes and then looking out at what's sort of getting produced, and there's tons of great stuff. And really, keeping up with all of it and figuring out how to package it and use it is challenging, even for us. And we've dedicated teams for it. And so if you're in the community, just kind of as an end user and consumer, it's a bit of a challenge. And so what we've kind of done is come up with an answer for being able to accomplish people's goals of being able to do blue-green canary deployments, Git-based workflows, easily deploying your applications, getting out of the business of managing TLS, at an individual service level. And so we package that all up, and that's really what Rio is, and it's really our aim and a take on being able to consume all of the great things coming out of the community in a way that makes sense and is actually consumable and really delivers what people really need, and that is these advanced workflows. And so the one that we're looking at, and is what we've observed actually internally, as a startup, we've experienced a lot of growth over the last year or so, and so we've gone from having a handful of people with 10 jobs each, to adding more folks, and to kind of alleviate that, I think we're down to 3 to 5 per person now. So, but what we can see now is that there's a lot more coordination, and there's this certain workflows where like a backend developer is developing the API, and the UI needs to be developed against that new API, or in kind of on our front end sites like Rancher.com, we've got changes of content, we've got changes of layout, new themes coming into play, all these new refreshes that are coming in, and so people need to see those changes or interact with those changes in interesting ways, before merging or committing to it and providing feedback. And it really lends itself well to kind of the GitHub-based workflow with PRs. And so in the latest release of Rio, I think we're going to be using the alpha version today, but I think there's an official 05 release coming out soon. What we've added is support for a user or a developer commits some code and opens a PR, and then from there Rio can deploy that, build it, deploy it, and update the status API in the GitHub PR. And so then the user can come and click on a link from the PR, get access to that UI, that API, and they can see the endpoint. That's all updated, and they can see the build logs, and where how that container was built and that service was updated. And when that PR is merged, Rio goes back and cleans up all of the PR revisions, removes them from the cluster, and then does a slow rollout to production. So that's the workflow we're going to look at today. It's a simple UI type workflow, but we think this feature is really pretty compelling. We're pretty excited about it ourselves. All right, so I've deployed, I've got it set up, I'm using a K3s cluster on a DigitalOcean box. And so what I've set up is the GitHub webhook. So I've created a namespace. I've added a secret, which is a personal OAuth token, which will wire up the webhook for me. You can see this on the docs. And then, make that bigger. So here I have my the service, and so the new flag that is now available is Rio run, and we've got this new flag added called build enable PR. So when you previously used to Rio run and enable it and give it the repo, now you can add this build enable PR flag, and that will wire up this this new PR workflow. So here's my Rio PS, and if I click on this link, I can see I have my Rio UI, and it's just kind of a simple basic UI. And then when I do, now I can come here and so let's create a branch with a simple update. So creating a new branch. Hit my index HTML. We'll have welcome to infrastructure as code with Rio. Just make a simple text change. Push this branch. So I push that up remotely. And so if I come to my demo, see, I can open up a new PR. You can see now Rio is a webhook has been fired off, and so now it's been requested a deployment to staging now. And so we can see that this is getting deployed, and it's in progress. And if we come back here and see Rio revisions, see I got a webhook event, and now things are getting built. It should be pretty straightforward. So now that's finished deploying, and I can click. So as a user who's coming in to review this PR, I can say, okay, I can come and view the PR. Or not. I can also see that here. I can see the build logs for this build, so that it pulled which images internally and how those got launched. And yeah. Oh yeah, it did show up. It's hello live meetup. So you can see we've updated and we have a new version to check out. And so if I'm happy with that, let's say merge PR. I can see that now I can see the different environments that staging was deployed, and now it's merged. If I come back and look at Rio, I can see a Rio PS. You can see that I have two versions now that are going out. I have the original and my merge, and so it's slowly shifting the weight from one to the other. And so that's now happening. Yeah, and so I had another branch that I was working on that just shows a bigger change. Let me see how that works. And so on this one, I've got more of a Hugo-based site with a theme. See, I've added 83 files, so this one's much bigger. And so this is now getting deployed, or has not been deployed yet. So let's send an event. That rollout's still going. Alpha software. Apparently it doesn't like this one, but you get the idea. So with these PR-based workflows, each PR is getting its own revision. So you can see there's multiple revisions currently running. If I was to have multiple PRs open at any given time, each user can go to those PRs that they're responsible for reviewing, click on the links, see them, interact with them, and then merge as appropriate down to master. And then all of that gets cleaned up on your user cluster. So we think this is going to really help in workflows where you have a lot of UI-based or marketing type changes, or if you have back-end developers and UI developers that need to interact with as they're building APIs and UIs on top of them. We think this is going to really help with the GitHub-based workflows. That's the demo.
Great. Fantastic. One quick question Jeff asked, you use GitHub for the integration. Does Rio also support GitLab?
Not right now. We started with GitHub first. One, I mean, GitHub's pretty popular, and two, we have some internal use cases that we want to start piloting with this as quickly as possible, and we're a GitHub shop.
Cool. So, but there's no reason that this wouldn't work with GitLab or any other Git-based service, right? And in the long run, that just needs to be integrated.
The tight integrations with these APIs would need to be adapted. But as far as Rio itself works today, it has mechanisms it just needs a Git repository. It doesn't have to be. It has non-Git webhook-based workflows that it can work with. So it just needs a regular Git repository, and it falls back to like a polling mechanism.
So if you were using GitLab, that's the way you would do this right now?
Today, yeah.
With Bitbucket or anything else?
Yeah, but you wouldn't be able to have this PR review process today in GitLab.
Got it. So if somebody wanted to, is that an area where someone could contribute that type of work in the community if there's interest in it or capacity for it?
Yeah. Rio is open source, and
yeah. So if you're interested in seeing another provider or anything, please file an issue on the Rancher/Rio repository, and I'm sure someone would love to work with you and help you kind of figure out how to add GitLab support. We love GitLab, so it's a great tool. And anything else? A couple other questions. Charlie asked, does Rio deploy out to Helm? Is Rio deploying out to Helm? Want to answer that?
Rio's controlled. It can deploy YAML files, or it will be able to deploy YAML files, or it has sort of a Rio file syntax that describes the services, and I think things are getting renamed, but there's a lot of work going on in Rio right now. But basically, Rio has a Rio file that allows you to describe the application and how you want it deployed and the scale and all sorts of things. So it's not using a Helm chart right now, but I imagine support for something like that could be doable. But yeah, it's mostly driven sort of off its own constructs at this moment.
So Rio, just to be clear too, as Bill said, this is a alpha release right now. It was announced back in June, so it's only about 3 to 4 months we've been working on it publicly. But we do have quite a few teams out there using it, I know already, and we've been getting loads of feedback and issues. So if you want to play with it, please give it a play, give us some feedback. We wouldn't recommend it for running in production, but we are working really quickly on it. So expect us to probably make some more announcements about Rio, in the next, I would say, 2 months or so. So it's definitely getting a lot of attention. Okay, there are a few more questions, but Bill, why don't I let you answer some of the ones that are on in here directly, and then I'm going to go through the last couple slides. We can wrap up, and then we'll get back to the questions if we have anything left. But I do want to really thank you and Taylor for spending a lot of time on this and going through it. I think it was really great to see all the work that you guys went and put into kind of building out these examples. And I've shared Taylor's GitHub repo in the chat, so if you haven't found that, take a look there. With that, I'll just wrap us up. For those of you who haven't set up Rancher before or still learning about it, you can go to the quick start guide on in our docs. If you just go to the rancher.com/docs, you'll find all of them for Rancher 2, for RKE, and there you'll find a lot of stuff about deployments, and certainly you can find, if you search in there, you find all about our Terraform provider. It's there as well. But the quick start guide gives you a quick idea for how to set up just a single node Rancher cluster if you want to play around and get some familiarity before you move into a production deployment like we talked about today. I talked a little bit about Rio. Today we talked about Rancher. There were questions about Rancher OS, K3S. I saw a question about K3 OS. We talked about Rio and RKE. So, you can tell we're pretty busy over here at Rancher working on a lot of different open source projects. As always, everything we make is open source. We don't have or sell enterprise only features. We make everything available to everyone, and we provide enterprise support for organizations using this stuff in production and commercial environments where they need 24/7 support. So if you're interested in that type of stuff, please don't hesitate to reach out to us, shoot us an email. We're happy to chat with you about what you're trying to do and if we can help in some way or another. Otherwise, we love working with people in the community. We love contributions. We'd love to have more contributors. So if you would love to get involved, please file an issue. Say, hey, let me get involved. Find us on the Slack. There's a contributors channel in Slack. So really, don't hesitate to reach out. If you haven't heard of any of these projects that we're working on, just Google them. You should be able to find some good information. Most of them have their own little websites. Longhorn's been, going through the process of, heading towards GA. RKE, K3S is getting close to a GA. So a lot of these things are moving pretty close to 1.0s, and it's going to be a busy, 6-12 months for us right now as these projects come together. But one of the cool things is seeing how how the layering of the technology is really coming together. K3S is becoming, has become incredibly popular, more so than we ever imagined when we released it. And as we build out Rancher 2.3, 2.4, we're looking at how to, really leverage K3S in, along with RKE. We're seeing a lot of adoption of Rio, so we are looking at that as well, and how to make that easier for people to consume. So just a lot going on. If you see things or there's things you'd love to see, please reach out and we're happy to chat. With that, I'll say thank you very much to our presenters and thank you to everyone for coming today. Feel free to shoot us topics or ideas you might like to see on the upcoming one, and we'll now kind of try to go through any questions that are left that haven't had a chance to answer. So the oldest question, poor Renat asked back almost an hour and a half ago. Renat, I apologize. You asked a question about cluster templates, which I had mentioned at the very beginning, and your question was whether cluster templates would include support for workloads, stateful sets, and other pods. I couldn't remember the answer to this. I know we talked about it in last month's meetup on cluster templates. Bill, do you know the answer to that question?
I mean, we plan to expand cluster templates to include other things like node templates and probably or possibly catalog apps. Really, though, but getting down to the individual pod level, probably not, or workloads. You know, that's more of like an end user Kubernetes thing. But certainly from a catalog app, and really sort of even in their absence in the current implementation, you know, coupling the cluster template for the RKE config, you know, really being able to address ensuring a compliant cluster is deployed every time and having that guarantee a deployment of your cluster configuration, plus using something like the Terraform provider by Rancher, you know, you can create a module that creates the cluster, uses the template, and then uses catalog apps through the Terraform provider. So you can have a module to create a cluster just the way you like it, through kind of your continuous delivery system, and also know that it'll be very secure, based on how you've decided to configure that. You know, Rancher will be enforcing that configuration.
Cool. There's another question. I think this is one I just asked. Daniel said, "Is Longhorn already part of Rancher 2.3?" It's not. When we talk about part of something, we're usually talking about something like Istio or Prometheus, which are sort of fully integrated components of the Rancher platform. Longhorn is not. Longhorn's available in the catalog, so you can launch it from the catalog. It's still a beta product, so we don't provide it as a kind of GA supported service. It is getting very close to that though, and so you know, stay tuned over the next couple months. I think we'll be making some Longhorn announcements. You can certainly deploy it from the Rancher catalog though very easily. It works nicely when it's implemented there. Another question. This one up. This one was from Alexi. He said, using the TFTP server at the L2 level, which listens when the machine starts and uploads the desired. Sorry, I got it. Okay, sorry. Here's the go. I found the question in here. He was asking if K3OS is planning to implement a package manager. Bill, do you know the answer to that? I don't know the answer if that's in the current plans for K3OS, an upcoming release.
No, I mean, sort of the goal there is that, you know, we'll get Kubernetes up and running as quickly as possible, and then you can deploy Kubernetes workloads like pods and you know, pods deployments, stateful set type things. And so from that standpoint, you know, the things would be sort of managed at that level, and that would be sort of your unit of package.
Okay. So there was a couple of questions about Terraform. Santhakumar asked if the Terraform provider support for vSphere based bare metal server for upgrading a Rancher. I think he's asking so most of the questions I saw about Terraform were really about support for different platforms. Like, would it work with different types of AWS services? Would it work with bare metal? Would it work with vSphere? We talked about this a little bit, but Bill, maybe you could just answer a little bit more clearly about what's the relationship between Terraform support for different infrastructure platforms and anything you're trying to do within Rancher, the Rancher driver.
Yeah, so your Rancher integrates a lot with your existing infrastructure or your existing workflows. So typically, like if you step back and take Terraform or anything out of the picture, right? Like you end up, at the end of the day, you need 3 machines. You need to install Kubernetes on top of them. And then once that cluster exists, you need to install Helm. You need to install the Rancher application through Helm, and then you need to configure it. And there's lots of different ways to kind of go through that process. And so, when you look at Terraform, to sort of automate end to end, you have to ask yourself, how am I going to get these VMs and so or these servers? And so that could be from a vSphere or an AWS or Azure or Google or Linode. It doesn't matter to us, right? Like we just need these components. And then when you want RKE, you know, it needs to know what are those node IPs, you know, and how do I SSH into the box so that I can install Kubernetes on top of that. And so each one of these is just sort of, you know, they're distinct parts of the steps in the process, and they have inputs and outputs that you can kind of plug together. And so Terraform, I think Taylor showed the docs link earlier, but if you click under the providers, there's a lot. There's vSphere, there's Google Cloud, Linode, GitHub has one. I mean, anything that really provides a lot of infrastructure to people, or probably has something, particularly certainly the most popular in those class types, has a provider, and so you can integrate that. And syntactically, everyone's got a different flavor, right? Like, you know, an EC2 node is different than an Azure instance, which is different than a Google node. And you know, each cloud provider has its own take on what things are called and how IPs get assigned, and security groups versus firewall rules. You know, so that's not abstracted away from you. So each of the providers has sort of like a specific configuration for each of those. But again, what you're doing with that though is really just layering. You're implementing the provider for that step, and then getting the outputs to feed into the next step. And that's really what you're doing. You're just layering these steps up. So vSphere is available, and it's something that you can get access to. The other cloud providers, really what you're looking for, you know, sort of that interface between the two steps is, you know, whatever's provisioning the VMs needs to hand the RKE provider a list of IPs, you know, so that it can SSH into and install what it needs to. And then that feeds into, you know, that step has to give a Kubernetes config file to the Helm provider to initialize Tiller, and then get things up and running that way. And then, you know, Helm exposes the IP address of the Rancher installation to the Rancher 2 provider, which then starts interacting with the API of Rancher. And so you're just sort of, you know, plugging along these different steps of a process and making sure that the outputs of one feed in as the inputs of the next step.
Great. All right, I think that covers it as much as we can go into it, Bill, so I appreciate that. There was a question from Jeff who said, the Rancher 2 cluster has an RKE config option that allows for a nodes list that has things like hostname, IP address, and role. What is the purpose of these? In my mind, by assigning those, it would actively deploy RKE similar to the RKE provider itself, instead of using the node_command callback process. Are you following that? You want to try and answer that question? You can probably see it in the question list.
Yeah. Taylor, do you have a little more? Do you know what the difference is there?
I'm actually not entirely sure. I'd have to try it, to be honest, to see exactly what it does. You know, mapping that back to, you know, Rancher functionality that I'm aware of. You know, I don't think that there's, you know, Rancher's RKE functionality works a little bit differently than the command line, and so I don't think that there is a way to have it reach out to existing nodes and run commands like that. I think the only thing it exposes is the, you know, that Docker-based registration command. So I'd have to look, and I could check with Raul, who's the primary maintainer of that module, to see what it's for.
I think, you know, yeah, it's an option. It's defined as an optional field. So I think in the context of Rancher, you don't pass that in. And Rancher generates the role for you, and then once you get the registration command, you pass the role that you want for that node as part of that command. and Rancher sort of handles figuring out what needs to be applied to it.
Yeah, my guess would be that it's not intended to be a user input field, but it's more of a computed or internal thing that's built into an RKE config when you actually run it. But I'd have to talk to Raul to find out for sure.
Awesome. Well, why don't we, Jeff, if you want to chat about this further, I know Taylor and Bill are both on slack.rancher.io. If you just ping them there, I'm sure they'd be happy to continue the discussion and probably pull Raul into the conversation. Charlie asked a question earlier. He was talking about trying to kind of set up CI in Rancher, and so he was asking about support for Gidia and Drone. He said, when I try to install Drone from the chart Rancher provides, I don't see how to use Gidia. There are no fields for auth authentication. What am I doing wrong? Do you have any idea, Bill, maybe how to help there? I'm not sure I understand the question well enough to.
Yeah, I pulled up the Rancher chart. So the drone instance from the Rancher library catalog has the Rancher formatted questions, and so it's got a drop down that allows you to select Gidia, and then it updates the fields within that UI that you would need to populate for Gidia to integrate with Drone. If you're using one of the Helm upstream version, what you'd have to do is go through the values.yaml file and figure out what the appropriate settings are. And typically there's a settings list that you can also get some docs on in the README file. But it's probably a field name that's somewhat generic, but that would be about it. Taking a look at the Rancher library one might also provide you some insights as to what those field names are.
All right, a couple more questions. So one question from Alexei, he said, and this was during the Rio discussion. Actually, Stephen asked for something like, I think maybe I'll go through both of these. So Stephen said, how would Rio work with supporting projects? For example, testing a new UI revision that depends on an API update in a separate repo. And then Alexei said, what does it look like for microservice infrastructure and staging URL? Will it somehow know to relate to the proper contour? I don't know if you want to take those separately. We can do one at a time, or if you want to answer them both a little bit on, kind of the provisioning of versions and URLs and staging URLs within Rio.
Yeah. So let's see if I can sort it. So Rio right now, it has sort of the basic building blocks of a deployment. It's sort of kind of a one-to-one, but it's built on some really powerful frameworks under the hood, and we just haven't bubbled them up yet. So you'll be able to do much more advanced deployment pipelines, and sort of how that interaction between two separate repos is probably more into that bucket. But that said, from an automatic magical standpoint. But if you were to have a separate repo that did have a deployment from this PR workflow, you could get a URL that's on that service mesh, and then you could interact with it through the UI development in a separate repo, just pointing to that endpoint URL. And so that would be fully supported. It's just the automatic linking between the two. I think we have a little bit more work to do, but certainly the way it's built today, you could do it with a little bit of manual, a little elbow grease.
Awesome. All right. Did we cover Alexei's question as well about what does it look like for microservice infrastructure and staging URL? Will it somehow know to relay the proper contour?
I'm not quite sure what the contour bit is, but I mean, you can have different revisions that are deployed in Rio and different weights and services, and they can have different endpoint URLs to access them. So I think in a more full demo of Rio, I think that could be explained. But yeah, if you need more clarification, I know a lot of our developers are in the Rio channel on our public Slack, and we'd be happy to answer that question for you in more detail.
Cool. Yeah, or feel free to ask again, and we'll ask one more time. Jeff had another question. He said, looks like we skipped the Rio deployment itself via infrastructure as code in the install-app folder. A few questions there. You were installing Rio via Rancher 2_app. What is the value add of Rancher app versus installing apps via Helm using the Helm release TF? You want to answer that? Yeah, Taylor, go ahead.
I did skip that. I forgot when I was doing that portion of the demo. I forgot that we restructured. So yeah, basically, not strictly relating to Terraform, but just sort of a catalog versus Helm, Rancher apps versus Helm standpoint. There's kind of a handful of benefits of using the catalog as opposed to installing stuff directly with Helm. One is that Helm's not aware of projects. And so the process of creating new namespaces and then inserting them into projects is, kind of a multiple step process, with Helm. And if you don't put it in a project, it doesn't show up in the project view in Rancher. And of course, if you have anything like project network isolation enabled, you won't be able to communicate, as well as the other Rancher features like, sharing secrets across, a project, or, sort of the project-based access management stuff. It's hard to take advantage of that a little bit with Helm. You would need to create namespaces, move them into the project, and then use Helm to deploy into that existing namespace. So that's a big one. One of the other sort of big ones, I think, is if you use Helm, you would need to install Tiller into the cluster. And Tiller is kind of problematic in a lot of ways because of the permissions that it requires. It's sort of a well-documented Helm thing, which is why in newer releases of Helm, in the alpha stuff of Helm 3, they're looking Helm 3 or Helm 2, whatever the newer major versions of Helm, they are looking to remove it completely. So to avoid that, in Rancher, we've done some magic with putting Tiller into a container, and it only gets spun up as needed to do a deployment, so it's not running in your clusters all the time. So from a security standpoint, you kind of get a benefit from not having to worry about Tiller being installed into all of your workload clusters. And then just in general, not related to Terraform. Well, actually, there's one more thing, I guess, that's somewhat related. The process of hosting a Helm repository is slightly more in depth, because you need to go through the packaging and creating an index.yaml and then hosting that somewhere. Whereas if you use the catalog, it supports just a straight Git repository. So it's a little easier, both just management of it and then also like access control can be controlled, via Git, as opposed to having to have some service hosted somewhere. And then kind of the final thing is, if you are having people, looking in the UI, there's the whole apps page, so it's easier to see the status of them and everything from there. And they sort of integrate, a little bit better in the UI perspective, because you can look into an app and see all the pieces that are deployed as part of it, which you wouldn't get, if you're just using Helm.
Okay, great. Thanks, Taylor. There was another question Renat asked. He said, are you guys going to implement groups, a groups feature? There's a users feature in Rancher, but anything you're planning around groups? And I know we support this a little bit with them, the auth, but do you want to talk about that, Bill? I know you've been working on that area.
We're working to support group assignment to different roles in Rancher. In particular, I know the one that most folks ask for is being able to assign an AD group to like Rancher admin level thing, or one of the global roles that we've got in the application. So we are doing some work there in kind of the 2.4 timeframe. But at the local auth level, not at the moment, although it's something we can certainly look at doing.
Thanks, Renat. Okay. One question from David. He said, is it possible to use auto-scaling group with launch template instead of static AWS instances for the node pools? There was another question earlier about auto-scaling, and a good question that's talked about how Rio auto-scales the app, but there's still a need to auto-scale the nodes in the cluster. Do you want to talk a little bit about best practices for that? Thanks for the good question, David.
Yeah, so the way that the EC2 node driver is sort of a one-to-one mapping between machines. And if you want to use ASGs today, in particular with 2.3 on AWS, making sure that you're using the Kubernetes cloud provider, we've updated in 2.3 our support of that. So when a node comes and goes from the auto-scaling group, in 2.2, it currently kind of lingers around there. In 2.3, we now make it so that what is shown in Rancher is reflective of what the Kubernetes cluster is doing. And so if you're running the cloud provider for AWS or any of the clouds, that is responsible for updating the nodes list in Kubernetes. So as that's getting updated, Rancher will reflect those changes, making it much better. And so if you want to do ASGs, we strongly recommend looking at the custom cluster and doing that with one of your other provisioning systems. Longer term, something that we're sort of looking into is adding the concept of a node pool as essentially being able to make that a bit more of a first class thing and having it responsible for either managing an ASG, it can handle the size and scale of it, rotate through the underlying AMI, rotate through a config, but basically taking on a bit more functionality than it does today. And I think until we get that sort of concept in place, it's a bit challenging for us to do it with just node templates. But it is something we're looking at and digging into. And if you have thoughts or suggestions or feedback, we'd love GitHub issues, or you can try and get a hold of us on Slack.
Yeah, as far as the Terraform example goes, using the custom nodes functionality that I sort of demoed, you basically just replace the AWS instance, that resource, with auto-scaling groups, and then some system needs to be plumbed up for custom metrics. If you want to do it based on stuff from Rio, you would need to to plumb up something that would trigger auto scaling of the nodes based on something from Rio, or whatever custom metrics you wanted to use if you wanted to actually trigger auto scaling to happen.
Cool. That makes a lot of sense. All right, guys, very last question. Jeff said, are there plans for the Rancher UI for a cluster to show some of the more non-standard API objects, such as CRDs and view CRD created API objects, etc.? Any plan on that?
Yeah, I mean, I think you'll see some work coming out around some more visibility into the Kubernetes objects underlying in the next few months. Yeah, that is something we're looking into.
Awesome. All right. Well, with that, I would say thank you to both of you guys again for the great demos and for the all the answers to all the great questions. And we'll say goodbye, and thanks a lot for everyone for being here today. Next month, I'm sure we'll be having a good discussion about Rancher 2.3. So have a great day. Thanks again, Taylor and Bill, and we'll talk to everyone soon. Bye-bye.
Bye.
Bye.